Good day, students. I welcome you once again to study session 4 of NSC 206, which will discuss the chemistry of lipids. Please sit back and enjoy this lecture. In study session 3, you have been introduced to the chemistry of carbohydrates. Another macromolecules that is of paramount importance in our daily life is lipids. Lipids are a group of naturally occurring molecules that include fat, oil, waxes, steroids, fat-soluble vitamins such as vitamins A, D, E, and K. It also includes monoglycerides, diglycerides, triglycerides, phospholipids, and others. The difference between fat and oil is that oil is a type of lipid which is liquid at ordinary room temperature, while fat is a lipid which is solid at room temperature. As you can see on your screen, you have the structure of the lipid. At the end of this study session, you should be able to define the term lipid and highlight some biomedical importance of lipids. You should be able to explain the concept of fatty acids. You should be able to explain the term fatty alcohol. You should be able to explain different classes of lipids and describe some common simple and compound lipids. Moving to biochemical importance of lipids. Lipids are stored as a source of energy in the body. Lipids provide basis for dealing with diseases such as obesity, atherosclerosis, lipid storage diseases, essential fatty acid deficiency, respiratory distress syndrome. Also, lipids form structural components of biomembranes and they act as thermal insulator. That is, it provides insulation against changes in external temperature. Also, lipids can act as electric insulator in neurons and they can act as metabolic regulators like in steroid hormones and prostaglandins. They can also act as surfactants and prevent collapse of lungs during expiration. Moving to diseases associated with abnormal chemistry of lipids. It is associated with obesity, atherosclerosis, diabetes mellitus, hypolipoproteinemia, fatty liver, and lipid storage diseases. Let's look at fatty acids. Fatty acids are derivatives of aliphatic hydrocarbons that contain the COOH group. They are aliphatic monocarboxylic acid that are mostly obtained from the hydrolysis of natural fats and oils. We have saturated fats and we have unsaturated fats. Saturated fatty acids do not contain any unsaturated bonds. That is, they have only carbon single bonds, while unsaturated fatty acid is a long-chain carboxylic acid containing one or more carbon-carbon double bonds. This type of fatty acid is classified further according to the degree of unsaturation as monounsaturated and polyunsaturated fatty acids. Let's look at the functions of fatty acids. Essential fatty acids are useful in the treatment of atherosclerosis by helping transporting blood cholesterol and lowering it and transporting triglycerides. Hormones can also be synthesized from essential fatty acids, and they enter in structure of all cellular and subcellular membranes and the transporting plasma phospholipids. They are essential for skin integrity, normal growth, and reproduction. They also have an important role to play in blood clotting, that is, forming the intrinsic factor. In addition, fatty acids can be oxidized for energy production and they serve important role in health of the retina and vision. They are important in preventing and treating fatty liver. Fatty alcohol is divided into glycerol and sphingosine. Glycerol is a trihydric alcohol, that is, it contains 3 hydroxyl groups and has the popular name glycerin. It is synthesized in the body from glucose. Glycerol is usually colorless, viscous, oily liquid with sweet taste. Glycerol combines with 3 molecules of nitric acid to form trinitroglycerin, that is TNT, which is used as explosive and vasodilator. On esterification with fatty acid, it gives monoglyceride, diglyceride, and triglyceride. Glycerol has a nutritive value by conversion into glucose and enters in structure of phospholipids. The sphingosine which it is the alcohol monohydrate present in sphingolipids, and it is synthesized in the body from the serine and palmitic acid. It is not positive with acrolein test. What are the classifications of lipids? Lipids can be classified into simple lipids, compound lipids, and derived lipids. Simple lipids are the esters of long chain of fatty acids with alcohols, which are known as triglycerides. Compound lipids are lipids that contain additional substances like sulfur, phosphorus, amino groups, carbohydrates, or proteins beside fatty acids and alcohol, and they are essential. They are classified according to the nature of the additional group as phospholipids, glycolipids, lipoproteins, sulfolipids, and aminolipids. Then the derived lipids, they are derivatives obtained by hydrolysis of simple lipids and compound lipids, which still possesses the general characteristics of lipids. What are some common and simple compound lipids? We have waxes, which are simple lipids which contain a fatty acid joined to a long chain alcohol. Waxes are usually insoluble in water and not as easily hydrolyzed as fats and oils. Waxes are used commercially to make cosmetics, candles, ointments, and protective polishes. Common waxes include spermaceti, beeswax, and caruba wax. Triesters of fatty acids with glycerol compose the class of lipid known as fats and oils. These triglycerides are found in both plants and animals and compose one of the major food groups of our diet. Triglycerides that are solid or semi-solid at room temperature are classified as fats and occur predominantly in animals. Those triglycerides that are liquid are called oils, and they originate chiefly in plants, although triglycerides from fish are also largely oils. Then we have the phospholipids or phosphatides, which are compound lipids that contain phosphoric acid group in their structure, they are present in large amounts in the liver and the brain as well as the blood. Thank you for listening and have a good day.